Turkey's rise as a global defense manufacturing power is no accident, but the result of a long-term strategic vision focused on technological sovereignty, precision warfare, and industrial modernization. At the heart of this transformation lies the Multiple Launch Rocket System program, a cutting-edge artillery capability designed, manufactured, and continually refined by Turkey. Modern warfare has redefined the role of artillery. Artillery is no longer simply an area saturation weapon. Today's battlefield demands precision, speed, and network integration. Turkey's MLRS program reflects this evolution. Designed to engage high-value targets with pinpoint accuracy at long ranges, Turkey's rocket artillery system incorporates indigenous guidance technology. Automation plays a central role. Robotic arms handle sensitive components to eliminate human error, while computer-controlled machining ensures micron-level precision in rocket casings and propulsion systems. Every component is digitally tracked from raw materials to final assembly. Precision is what sets Turkey's MLRS apart. Modern Turkish rockets are equipped with GPS, INS inertial navigation system, and a hybrid guidance system that drastically reduces the circular error probability. In practical terms, this means targets can be hit within a few meters, rather than hundreds of meters. Modern MLRS systems do not operate in isolation. Turkish rocket artillery is fully integrated into a network-centric warfare environment. Digital fire control systems connect launchers to UAVs, radar units, command centers, and forward observers. In the Warhead Integration Hall, engineers assemble a variety of payload types, including high-explosive fragmentation warheads, thermobaric warheads, and special penetration warheads. This flexibility allows the MLRS to attack armored formations, fortified positions, command centers, and logistics hubs. One of the key features of the Turkish MLRS is its advanced solid-fuel rocket motor. These motors are engineered for consistent thrust, minimal deviation, and extended range. Inside the factory, propellant mixing and casting takes place in a climate-controlled environment to maintain chemical stability. Engineers use simulation software to model burn rates, pressure curves, and flight profiles before a single motor is manufactured. Each rocket motor then undergoes non-destructive testing, including X-ray scanning, ultrasonic inspection, and thermal stress analysis, to ensure flawless performance under combat conditions. Entering a Turkish MLRS factory reveals an industrial environment, more akin to a high-tech aerospace facility than a traditional weapons factory. Production is divided into highly specialized zones, each responsible for a critical stage of development. These systems are developed primarily by leading Turkish defense companies such as Roketsan. In close collaboration with the Turkish Armed Forces and national research institutions, the result is an artillery ecosystem capable of responding to asymmetric threats, conventional warfare, and high-intensity conflict. Inside the guidance assembly unit, microelectronics are manufactured and integrated under cleanroom conditions. Software engineers work alongside hardware specialists to encrypt the navigation system, making it resistant to jamming in electronic warfare. Continuous updates allow the system to adapt to evolving battlefield threats. Another key innovation is modularity. The Turkish MLRS launcher is designed to be mounted on a variety of wheeled and tracked vehicles, enabling rapid deployment across a variety of terrains from deserts and mountains to urban environments. The launcher assembly line focuses on hydraulic systems, stabilization mechanisms, and digital fire control integration. Each launcher is capable of firing multiple rocket calibers, allowing commanders to choose between ranges, payloads, and mission types without changing platforms. Safety protocols are stringent. Blast-proof chambers, remote handling systems, and multi-layered inspection processes ensure worker safety and product reliability. Each warhead undergoes balanced testing to maintain flight stability and accuracy. Inside the factory's software development wing, engineers simulate battlefield scenarios using real-time data feeds. This allows the system to receive target coordinates, calculate a firing solution, and launch rockets within minutes. The result is a sensor-to-shooter cycle that dramatically shortens response time. Before delivery, each MLRS unit undergoes rigorous testing. Environmental chambers simulate extreme heat, cold, humidity, and dust. Vibration platforms replicate the stresses of off-road mobility. Live-fire tests, conducted at a secure firing range, validate the system's range, accuracy, and reliability. Data from these tests is fed back into the design cycle, enabling continuous improvement. This feedback-driven approach has enabled Turkey to rapidly develop its MLRS capabilities compared to traditional defense development timelines. The Turkish MLRS factory is more than just a production site. It is a strategic asset. Domestically manufactured rocket artillery reduces dependence on foreign suppliers, strengthens deterrence, and enhances operational independence. As global interest in cost-effective high-precision artillery grows, Turkish MLRS systems are attracting increasing international attention. Exports, co-production agreements, and technological partnerships position Turkey as a key player in the global artillery market. The factory itself has become an example of how a burgeoning defense industry can rival established powers through innovation and integration. Within the Turkish MLRS factory, precision is not an aspiration but a standard. From digitally engineered rocket motors to encrypted guidance systems and modular launchers, every component reflects a philosophy centered on accuracy, adaptability, and technological sovereignty. As modern warfare continues to prioritize precision over quantity, Turkish rocket artillery serves as a powerful example of how advanced manufacturing and strategic vision can redefine battlefield dominance. Field dominance.